Part A. The 6 kg ball started out with a momentum of 6 times 2 equals to 12 kg meter per second, whereas the 2 kg ball started out with a momentum of 2 times 12, which is 24 kg meter per second. So the 2 kg ball started out with a much larger momentum than the 6 kg ball. We know that during the collision, the forces experienced by these two balls are equal in magnitude. They are action and reaction pair, Newton's third law. Since force can be equated to the rate of change of momentum, we know that both these balls will be losing momentum at the same rate. So the 6 kg ball is going to come to rest first, simply because it has a smaller initial momentum. For part B, we notice that the initial total momentum is not zero. We started out with a total momentum of positive 12 plus negative 24. So the total initial momentum is negative 12 kg meter per second leftward. And we know from the principle of conservation of momentum that the total momentum must remain as negative 12 kg meter per second throughout the collision. So if both the balls were to come to rest at the same instant, that would imply that the total momentum is zero. And that's a clear violation of the principle of conservation of momentum, which means this is never going to happen. Let's move on to part C. Before you do the calculations, it's always good to draw a simple diagram showing the scenario after the collision. I'm going to just assume that after the collision, both the balls will be traveling towards the right with velocity v1 and v2. We can form an equation out of the principle of conservation of momentum. So the total momentum before the collision, which is 6 times 2 plus 2 times negative 12, should be equals to the total momentum after the collision, which can be written as 6 times v1 plus 2 times v2. Because this is an elastic collision, we know that the relative speed of approach is equals to the relative speed of separation. So before the collision, the two balls were approaching each other at the relative speed of 2 minus negative 12. So they were approaching each other at the relative speed of 14. And after the collision, they were moving away from each other at the relative speed of v2 minus v1. And the rest is mathematics. So we have two equations here. After solving the simultaneous equations, we get v1 is equals to negative 5 meter per second and v2 9 meter per second. Let's move on to part D. So this is the velocity time graph for the two balls. You should be able to tell very quickly that the steeper line here, the green line, belongs to the 2 kg ball. This is because during the collision, the two balls experience the same force, the same magnitude of force. So the lighter ball will experience a larger acceleration, which shows up as a steeper line in the velocity time graph. This is the momentum time graph. Again, during the collision, the two balls experience the same force, the same magnitude of force. And since force is directly proportional to the rate of change of momentum, we know that the rate of change of momentum for the two balls should be exactly the same. That's why these two lines have the same steepness, which makes it obvious that the total momentum of the two balls is going to be a constant throughout the interaction, before the collision, during the collision, and after the collision. And lastly, the kinetic energy time graph. Using the formula half mv square, we can calculate the kinetic energy of the 6 kg ball to be 12 joules before the collision and 75 joules after the collision, and likewise for the 2 kg ball. So the total kinetic energy before the collision is 144 plus 12, which is 156, and after the collision, the total kinetic energy is also 156 joules. This makes sense because we are told that this is an elastic collision, so the total kinetic energy before and after collision should be the same. Part E is actually very easy. For a completely inelastic collision, we know that after the collision, the two balls will be moving off at a common velocity. So, by the principle of conservation of momentum, the total momentum before the collision should be equal to the total momentum after the collision. So after the collision, the two balls will be traveling at a common speed. So it's as if there's a 8 kilogram ball moving at the speed of v. And from there, we can calculate v to be negative 1.5 meter per second. Okay, I hope you have learned something from this example, and thank you for using XM Physics.